Okay, we should be live now. Let me know that you can see everything and hear me properly. Under the assumption that you do, welcome everybody to episode 5 or episode 2, depending how you view it. This is the second episode of the natural language processing series, where we will cover the concepts related to text canonicalization, specifically stemming, lemmatisation, and stop words. This is the plan for today in terms of the new material that we're going to cover, as well as covering some of the review that we did, about what we did last time, and with the hopes that these will all join together. And hi Mateusz, hi Anthony, good to see you. First and foremost though, I wouldn't be myself if I didn't start with the thank yous to all my supporters, friends, and everybody that is giving me feedback, as well as supporting the channel through subscriptions and Patreon subscriptions as well. I'm really glad that this is indeed happening, and I'm proud to say that we're very close to 500 views of the first episode, which for a small channel like this is, to me personally, quite an achievement. So small successes and moving forward. I'm glad that this is finding an audience that is interested in natural language processing elements, and an industry and a branch of data science and linguistics that is gaining in popularity in today's industry across the world. We have our Discord channel that is attached to the descriptions. All the other links are also there, so if you find the material interesting, hi Człowiek Wykres. Człowiek Wykres, now that he showed up, is our moderator for today. He will also try to the best of his ability answer the questions that you potentially may have regarding the material and the content at hand. So ping him, and he will ping me the question as well, and I'll be able to answer. I'll try to monitor the chats to the best of my ability, but sometimes when I get entangled in the material, then it's hard to monitor both. Okay, so without further ado, are there any questions at this stage? Any questions that I potentially may answer before we begin? Because we will begin with a short review about what it is that we've covered last time, and then move on and join it logically with the new material that is the subject of today's thing. Okay, so last time we've covered, yeah, this is the plan for today. Last time we've covered the branches of linguistics, and we've talked about phonetics and phonology as being the study of sound and sound systems as understood in various languages across the world. Then we talked about morphology, which is the study by definition of form, and in the linguistic context, it means it is a study of words and words' internal structures as understood by different languages from different perspectives. And this particular branch of linguistics will be under the particular focus and scrutiny today, because this is where we will be looking at words in detail. Then we also talked about syntax and grammar, whereby syntax and grammar would be the sentence level of language analysis, where we analyze the words as they come before and after each other, and what kind of replacements we can find in there in order for the grammatical sense to be retained. We also mentioned semantics a little bit, where we mentioned it was a study of meaning. Looking good, thank you. Hi Jacek, good to see you. We talked about semantics, which was the study of meaning and semantic features of words that we'll be discussing in detail as we come back to the word embeddings and how they're understood by today's models and systems. We also mentioned pragmatics, which was the study of meaning in context. So the all ideas about sarcasm, irony, metaphors, and all these elements. We briefly discussed discourse analysis, so the idea of language relativity and linguistic determinism, through the lens of the Sapir-Whorf hypothesis of the view of reality and relative centeredness of the world for every individual. And we also mentioned the psycholinguistics, and so how individual people speak, sociolinguistics, something without deep knowledge about linguistics, some chatbot in the shop page. Yes, all this is coming. Mateusz. The practical side of this, I need to have the foundations covered. Once I have the foundations covered, you will see how they all translate into practice. So this is all coming in the latest stages. And today we'll see some practice as related to the text canonicalization in practice as well. So yes, there is a lot of practical elements in there. So I need you to understand the relationships between linguistics and NLP. Otherwise, you'll just be a black box developer, black box analyst that just looks at the models and the code without the domain knowledge. That's very important to me. Okay, so that's the branches on linguistics. We also looked at, where is my tablet? Yeah, I seem to have misplaced it somewhere. Okay, we also looked at the examples of how we can measure the relationships between words, whereby we looked at the cosine similarity between two vectors. And the idea was that the closer one lies toward the other, the closer in meaning and in relationship they are. And we also studied the Euclidean distance between those two vectors to also measure the relationships between them. Okay, if you have any questions about this, I'm going to show you some mathematical noodles from last time. This is the mathematics behind it. This is exactly what we've implemented last time. In terms of the cosine similarity, we literally translated this formula into code. And we also literally translated this formula into code to see exactly how these vectors are represented mathematically, as well as what they mean in practice when it comes to analysis of language and words. Okay? So this is what we've done last time. With that in mind, let's move on to the new stuff. I'm going to quickly talk about morphology, talk about the linguistic element of it, and then we'll move on to the examples. Okay, so what is the morphology? Morphology, as the name suggests, is the study of morph. And morph means form. So it's the study of form. Hello, Yellow Bunny. The study of forms. So in this particular context, it is the forms of words that we're going to study. An independent example of a form, a word form here, is called a morphing in linguistics. What a morphing is, and I'll give you plenty of example of it, is the basic element of a word. Okay? So by this token, we divide them into free and bound morphemes. What that means is words that can stand alone in a sentence, and elements of words that require some kind of a stem to be attached to in order for it to make sense. Does that make sense? Let me know in chat if that makes sense. If not, I'll explain it in a different way. So within the free elements, we have two particular examples. We have the lexical morpheme and the functional morpheme. And I gave you the examples of have and have, because they function in the word have functions in two different ways in English. And try to think, what would the difference be in those two particular representations of those morphemes? What is also crucial And this is something where the text canonicalization comes most into play, is the inflectional and derivational elements of it. And I'll explain what the differences are. We'll also talk about when to use which and when to get rid of those and when not to. That's also important. So, we have these examples. I'll show you exactly what I mean in practice and how they're represented in different languages. This is an example from Swahili. The Hakuna Matata, everybody heard about this, but this is not this particular example. This is a representation, and I need to find my tablet again. I will, you love. That love. That's an example of one word that is represented in the meaning of I will love you. So you see, these words are very much close together. It's basically one word that represents an entire sentence in English. That means that within this study of text canonicalization, we need to pay particular attention to what languages we analyze and how do we go about stemming and lemmatizing them, because they will behave differently and you will potentially lose some important meanings of embedded in those words because you removed the endings of things. So it's very important for you to focus on what it is, what language it is that you study, and how the morphology of it works. Otherwise, you'll get yourself into trouble, and I'll show you an example of this later, even within English. The next example is just a simple representation of the morphological decomposition, as we say. So we can see the child's wildness shocked the teachers. The child is the basic stem of this. S is the Saxon genitive, right? So basically the possession. All the other elements attached to the words, I even have two here. One is a teacher, and then it's plural. So this is how morphology works, and this is how deep we need to look into the words before we actually decide to stem them or not, because that will inform the models later on. If you have any questions, because this is important, if you have any questions, do ask them, because it's crucial for you to understand all these concepts. Okay, more examples, just in two other languages. Again, English, just to show an example how this works and how it's made up of different morphemes. How a given word is made up of different morphemes, or can be made up of different morphemes. And also another language, and I think it was Tagalog, sorry, which was the language of Philippines, but I may be wrong here because I can't remember. I created it some time ago already. So this means to die, this means to cause to, and that means future, which together translates into will kill. So you see how much meaning there is embedded in different parts of words, let alone sentences, as you'll see later, to convey certain meanings to a listener when you're speaking to them. So that's how deep the meaning goes when it comes to understanding different languages and being able to decode and encode messages in them. All right. How does it work in general? And I will need to find my tablet now. Give me 2 seconds. All right. So you've seen some examples of words that take on different compact elements of to them, and therefore convey different levels of complexity when it comes to meaning and understanding. There is actually a study that classifies those languages according to the level of complexity within that word, within particular words, in order to convey certain meanings. And we're going to show you. I'm going to show you really quickly how this works. How this works in practice. So the topic here, synthetic and analytic languages, is an indication of what it is. What does it mean if that something is synthetic? What does it mean that something is analytic? In general, not only with in the context of language, but also in general in the world. What do we call a synthetic? What do we call synthetic data? What do we call synthetic materials? What do we call, why are they called synthetic? Why do we call other things analytic? And what's the analysis behind it? In the context of language, as I'm going to show you, it means the following. If we focus on analytic, it's going to be, forgive my penmanship again, and we're going to have synthetic. Okay, not natural. There was something about banking as well. It's not natural, it's artificial in a way, maybe. Yeah, if that's what you mean. In the context of linguistics, the more synthetic something is, the more information there is embedded in a particular word. What that means, there is a lot more components packed in that word, rather than representing everything step by step. Okay, fair enough. And analytic means you can break them down to pieces, and often it is showed overtly in the language. So what do I mean by this? An analytic language, sorry, to the most extreme spectrum of analytic languages, we have languages such as Chinese or Japanese or Korean, for example, where everything is shown in isolation. So we call them isolating language. Right? So, for example, I'll show you an example. This means I. I'm sorry, my penmanship is bad. This is I. This means possessive, which together means my. Two characters separately represented in language that mean my. Only one thing that we need in English for it to be represented. So everything is explicit, everything is overt, everything is shown explicitly to the speaker. The next level, what is happening? Oh, the next level is let's call it agglutinative. Agglutinative. The idea is glue. We glue things together, which means we change some morphemes in order to fit the particular word and thus convey meaning. An example of a language like this is Turkish. While I do speak Chinese, I don't really speak Turkish, so I can't give you an example from it. So we call it agglutinative. An example of this would be Turkish. The next level, see, I can't write properly, is fusional. Okay, I had a conversation with a friend recently about how do you say I ate in Spanish. Because Spanish is an example of it. So Spanish. And apparently it's comi, and correct me if I'm wrong. This means that this is first person and past tense. Two pieces of information included in one morpheme. That's why it's a fusional language. Does that make sense? Okay. And the last group is polysynthetic. Polysynthetic meaning, and these are the examples of the far north, like Eskimo language, for example. where everything is together. You can see words that are 2 lines long and they convey entire meanings of entire paragraphs probably. Okay, so these are this is the breakdown of the analytic and synthetic continuum, and it's important for us to understand in which group a given or particular language is in order to deal with it. This is particularly important in projects that let's say deal with multilingual approaches. So for example, companies that deal in different countries and have their systems in different languages, and you need to do something with all of them. It's important to look at each of the languages and at least classify them according to this in order to see how the stemming and lemmatization could work in this context. Okay, so this is everything that I have in terms of the theory of linguistics here. If you have any questions, by all means tell me, and with any luck we should be able to move on to our practice. And I'm going to check whether there are any questions. Okay, so far everybody understands everything, at least that's my assumption. Okay, so the primary library that we're going to look at today is, unsurprisingly, NLTK. Okay, so the first thing that we're going to look at, NLTK is the Natural Language Toolkit, and this is the basic introduction to this library when it comes to stemming and lemmatization, simply because it's very easy to deal with, but a lot of examples can come out of it. I'm going to copy some of the examples of texts that I've prepared, and in this way we can actually save some time to find some text online, but this is text that I literally found online and just copy them into the as paragraphs into the code. So okay, so we're going to be dealing with lemmatisation first. What is the difference between stems and lemmas, or lemmats, some people say as well? The idea is that if you look into a dictionary and look for the word went, for example, it would refer you to the word go, as went is the past of go. So the basic dictionary form of a word is what we call a lemma. Don't confuse it with mathematical lemmas. This is a linguistic example of it. So what we're going to do is import or assign an instance of the wordnet lemmatizer to our variable lemma. So we're going to use the wordnet and use the wordnet lemmatizer. With any luck, you should be okay. So I'll give you an example. Lemmatize. The plural of leave is leaves, and it gives us the base form of the word. Yeah. We can actually specify, we can go slightly further, and if you look at the document, yeah, POS in this context means part of speech. We can tag this as part of speech, and look at the example. This is now automatically, as or by default, assigned to noun, but take a look at this. If we assign it to a verb, base form will change, because this is also the third person singular for the word leave, so to depart from a place. So you see how this behaves differently depending on what part of speech it is also understood as. Okay, so I'm going to import another library that we're going to look into, and this is going to be wordnet lemmatizer, and we're going to play around with those parts of speeches. So parts of speech replacement, this is what we're doing. Is this only limited to English, or would you translate to English? Would you translate your target? No, it's not only limited to English, although it is the best training that they did on it was in English. So the word net is focused on English, but there are other lemmatizers and stemmers that also work with other languages. I'll show you an example of this. Just one one stemmer that we're going to look into that is going to be in other language. But these are definitely not limited to them. In some cases where the languages are not so, in inverted commas, popular, and not too much research has been done into it from the linguistic or NLP perspective, they will need a special care and attention when it comes to how you lemmatize, and probably you wouldn't even, in many cases, get down to the level of regular expressions in order to handle these properly, which, trust me, can be a bit of a bummer. Okay, so we're going to create just a simple list of some examples of words in different forms. So walk, walks, and walked. And then maybe a noun of some sort. Let's just say dog. And it's going to be dog, dogs, dogs, and dogs. And look at this. Dogs, which is the possessive, right? And maybe one more, grass. And we're going to look at grassy. I'm giving it different parts of speech just to see how they will behave. Grassier and grassiest. Okay? So, lemmatized walk. What we're going to do, we have a position rep, and we're going just to give it a word, give it a part of speech, in this case it's our verb, and then for word in walk. This one closed, this one closed, and this one closed. Cannot import from word, yes, because that's it. That needs a capital N. Okay, so now if we look at ties walk, it will give us a part of speech here. Okay, we'll see how, did I do something, because I wanted to show two things at the same time, but maybe I haven't. Set, okay, position rep. Yes, obviously, it's a method. Yeah. So now you see all these elements are lemmatized into the base form. Okay? The same thing we can do with dog. A lemmatized word in dog, and then this is what? Grass. I'm giving you different parts of speech. Grass. Okay. Let's change this. Dog, dog, and dogs. You see, so there is already, we have a problem. It does not catch all of the forms and try to bring them to the base form. It doesn't understand everything. Okay? And to give you the third example, grassiest, grassier, grassy, no idea. It has no idea what these words mean, so therefore it returns just the same thing. It cannot lemmatize it. Okay? Okay. And a different example, I'm just going to give you some irregular words. So we're going to do the same thing. So I'm just going to go over this. Just say child, children. Yes, correct. You can use the other languages, like I said, there's different levels of implementations of lemmatizers and stemmers in different languages, and sometimes you just need to do it manually, which is a pain. Honestly, it's a pain. Okay. This is the first irregular example, which again was not understood properly because we're giving it the wrong part of speech. Okay. And then just another example, lemmatized, irregular, another word maybe. Any other idea for a word that you might want to look into? Position reflects word, and we're gonna do maybe do like do and did, for example. Sorry, for word in do and did. Okay. All right, and it understands this. So some implementations, as you see, work, and some of them, as you can see, sorry, where is it? Some of them here do not. Why? I'll leave the question to you. Okay. We're going to have a look at two different types of stemming and lemmatization. Two different types of stemming, or maybe three, we'll see. We're going to do so now we're going to move on to stemming. So from NLTK, stem, import, we're going to import two. In previous example with the walk, dog, and grass, you use V. Yes, because the idea is that we're replacing a part of speech here. We're not trying to tag it as much as we're trying to replace. So for example, if we did A for adjective and we did noun here, right? It will understand this, but it cannot always convert to, because there is, maybe I'll explain it a different way. English language is generally very productive, and what that means in practice, you can use a lot of words as as verbs. As you can Facebook somebody, you can tweet or Twitter somebody, you can perfect something, and therefore, in certain cases, some of the examples should be able to be translated into other parts of speech, and lemmatization sometimes fails to do that. And you need to be able to be very careful about how you handle these parts of speech, because otherwise you may end up in the way that we just did in grass and grassy and grassier and grassiest. Okay? Porter stemmer, which is, and we're going to look at Lancaster. Okay? Now, this is where I borrow my text. Just to be quicker. Okay. So what does it say here? Maybe we should just start a terminal so that it's smaller so you can actually read it. Yeah, that's much better. Okay, so what does it say? The second point is that with the approach adopted here, the use of suffix list, blah, 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 blah. This is taken actually from a Porter stemmer, no problem, Mateusz. This is taken from a Porter stemmer algorithm explanation article from 1968, I want to say. Might be off by one, but around there. And let's see what we can do in terms of this stemming. So we're going to do PS, which is our Porter stemmer, and LS, which is not listener command line argument. example, just Lancaster, stemmer. And we're, as a bonus, and this is to answer your question, Anthony, that you had earlier, NLTK, stem, snowball. I just remember there was such a thing. And here, in the snowball stem example, in English. Okay? So if we have a look, let me just close this and open a snowball stemmer. And type in languages. You can see algorithms. Where do we check? Languages list, maybe? Snowball, porter, stemming. It doesn't like algorithms. English. Okay, here it is. So we have groups, and we'll talk about what these languages as groups mean, not only from the syntactic and analytic perspective, but also where they come from. All the languages that you have here, Scandinavian, Germanic, Romance, and believe it or not, English is a Germanic language. So it is in the same, wow, this is bad spelling. I mean, bad writing. English is a Germanic language, therefore it has the same implementation as here. And for English, actually, it uses porter stemmer anyway. But it's an interesting thing to know that there is a stemmer available too in different languages. Okay, but look at this. I'm gonna just post it in one cell for you to see. Maximum. Stemmed by the porter stemmer, no problem. We're just going to replace this with L for our Lancaster stemmer. You see, there's already problems here. Maximum is a perfectly valid free morpheme, and yet, according to the Lancaster stemmer, it is not correct and it needs to be abbreviated, which is not entirely correct. Okay. Where is our, oh, we already have our rock and dog, so we're doing the same thing. I'll speed up real quick, just to show you. Just to show you how the porter stemmer works, and because we'll move on quickly because we're running out of time. Okay, stem, and we're going to do word, forward, in walk. Okay. Again, no problem. And dog would also give the same. I'm not going to retype the same thing. So lemmatisation and stemming in this case work very similarly. Okay. So let's look at the following. Irregular verbs. Again. Do, did, woman, and as we know, women. Okay. Irregular verbs. We'll see ps.stem. And we need word, for, word, in, verbs. Okay. You see, again, nothing happened, which is a good thing in this case. Okay, so this is some examples just on to how to handle the stemming and lemmatisation in different contexts, and you see how much thinking there is involved when it comes to which words you look into. And as you do your statistics on your text, in terms of what we did last time on how many words there are in a particular text, you will also make some decisions on which stemmers to apply to the stemming and lemmatization. Yes, that's the summary. Exactly. Stemming is cutting the end of words in a specific way, and lemmatization is back to its base form, which is the dictionary form of the word. And you can see there are some edge cases where it fails, fails conspicuously, because it doesn't know what to do with it. Even in the most studied language from the NLP perspective, that is English. That is very much true. Okay, so coming back to our text. Sample text, yeah, it was. Yeah, there's C in text. Look what happened. We tried to stem the text, and we just got the text back. Granted, it was lowercase, so the case was lowered, but we only got the word. We only got the same words, so you can see, oh, nothing's changed. Why is that? The reason is that we need to tokenize the words. So that means, tokenize the text, which means divide the text into words. So let's do that now. We need some tokenizer. Okay, import word tokenize. If I can, I'll bring this up here. These are stop words in stop. I threw it away. Yeah, I did. Hold on. There's too many things going on. Stop. Stop words. These undergo lemmas and stems. Yeah, so this is how they map it to each other when it comes to the morphological example. Okay, so thank you very much. You can go now. Okay, so coming back to our examples, yeah, the navigation in Jupyter Lab is still leaves a lot to be desired. And we're going to need corpus. Just going to need stop words, okay? And stop words are those words that are functional in the morphing categories. So like have been and the word have, will do, the word will, blah, blah, blah. These are examples of functional morphemes. So let's tokenize our words. So divide the text into words, yes. Tokenized text. So words tokenized. But thankfully, the applications of those methods is easy. And we would probably need the stop words. I'm going to show you what they are. Stop words. And we're going to just unique words. And again, we can choose the language here. We in fact have to choose it. Valid corpus in, and yeah, that's, yeah, you see all these words are considered stop words, therefore functional morphemes in English. About, above, blah, 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 blah. They can stand on their own in a sentence, but they only function as grammatical components. Okay, so coming back to our tokenization text, we just lowercase it, and then tokenized. Okay, this is our tokenized text. So words, text divided into words with certain surprises, full stops, other elements that are not supposed to be there. but yet here we go. Okay. Okay, so now let's try and remove those stop words. And this works in some cases and it doesn't in others. So without stops, we're gonna do word for word in tokenized text. If words not in stop, right? Okay, you see how much shorter the text got, because we simply got rid of all the grammatical functions that are in there. And this is useful in some models, especially machine learning models. Don't ever do that in deep learning because the meaning is lost. And I'll show you an example very quickly about this. Okay, I have an example of sentiment analysis. Which we'll be talking about extensively. But here is just an example to prove a different point, right? Sentiment analyzer, yes. And we're going to just sentiment intensity analyzer, sentiment, okay, we're just going to create an instance, and polarity. So how positive or how negative something is. And this is taken from an article that I wrote. He hates broccoli. Or it could be spinach or something. Just imagine something you don't like. Okay? And we're going to take this thing, print it here again, and change just this into polarity scores, obviously. It's not. Okay, so you see, 60% chance that it is negative, 40% chance that it is neutral. Okay, remember those numbers. So in the other case, hated is 67%, 68% if you round it, chance that it is negative, and 32% or 33 again if you round it. No, it's 32 even if you round it, that it is neutral. So you see, this is the difference, and this is why stemming and lemmatization doesn't always give us the best information. This is only for practical calculations of algorithm that you'll be implementing to make it easier for the computer to analyze long text. But it doesn't always apply, it doesn't work well every single time. And it is often difficult to decide whether you should or should not, and testing and experimentation and research is important in this context to make sure that you have the best results possible. Okay, we're getting closer to an end. I see the chat is still quiet, therefore I'm assuming that everything makes sense so far. These are just simple examples of why stemming and lemmatization work and why they don't work and how to approach them. Okay? Now, I have a bit of a bonus for you to show you an implementation of something you may potentially know. Anybody heard about the Huntsville? It's actually interesting. As you know, and I've prepared this as well for us to not lose time, but I'll show you something. Take a look at this. Telegram, the famous communicator or the WhatsApp equivalent of non-Facebook products, has actually an implementation of word suggestions based on the lemmas and the stems that we just saw in our analysis of the text. What does that mean in practice? I have a documentation for you that I'll include as a link to in this notebook as I publish it on GitLab, to which you can find the link in the description. These are all the methods of this particular library, and this is exactly LibreOffice spell checker as well. There's many different implementation, and it's actually as easy as 1, 2, 3 when it comes to see how we can play around with it and add our own words. I'll make this bigger. You can even add your own words. You can even add extra dictionaries if you think that there are some problems with it, or just for fun. So you can check what replacements you can add to the current dictionaries in your own languages to see if you can play a trick with somebody. You can add different affixes. You can add different word generations even. You can generate morphological structures for a given word. So let's play around with it a little bit, see what we can do. Okay. So that also needs to be some kind of a variable, so let's just call it age object. Okay. So now, word suggestions. Let's say the word sadder. All the morphological structures that are here are given as examples of what it can be replaced with. Okay? Sadden, sander, ladder, gather, matter, bala, blah, 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 right? Let's say that we want to analyze a word. Sadder. Okay? Now, each string here, just show you real quick. I just lost it. Analysis of the input word. Really strange how it navigates around, and we can read exactly how it works in practice. So let's do that. This is a really strange navigation system. Okay, all the documentations, all the links will be included in there. So have fun with it, play around with it, see what you can do. Even on Telegram, on other spell checkers or word completion documentations in different chats and so on and so forth. See what we can do, see what you can change, how it behaves, and how does that relate to the stemming and lemmatization concepts of how we canonicalize the text, and to make it more standard and to make it more prone to further analysis in terms of text classification, named entity recognition, and so on and so forth. Okay, so with that in mind, do you have any other questions? Is there anything that is unclear? Because we'll be going slowly and surely to a project after we've covered the basics of linguistics and basics of text analysis from the pre-processing perspective. We'll be moving closer and closer to a project that I've prepared for you on text classification, because this is, as I promised, the first implementation of NLP, and we'll be looking at all these strategies that we learned previously and today as they implemented in the project, because it's important for you to know them and remember them to do this correctly, and most importantly, consciously, which means you control every step of the way of what it is that you do. Okay? So, are there any questions? If not, I would like to again thank everybody for being here today. Do visit our Discord, do visit the further videos about this. Let me know what you think, and I'll see you in the next episode, which is next week at 6 p.m. CEST. And I'll see you all on Monday as well for our Polish stream at the same time to continue our adventures with pandas on the hard level. And we'll probably be implementing Minesweeper as far as I remember. All right, so with that in mind, thank you very much everybody for attending, and I'll speak to you